Hello everyone. In this video, we're going to go over the various technology things in StatCrunch that you'll need or that will help you in completing this week's assignments. So we'll start with Lesson 6. In the Lesson 6 videos, I went through and I talked about sampling distributions, and at the end of each of my examples, I asked you or I went about showing you a probability or asking a question that I hoped to answer. Unfortunately, at that time, StatCrunch wasn't working for me, okay, or I wasn't able to show you StatCrunch, and so I'm going to do that now for each of them. So the first example was this coin flipping example, okay, and I go through and I create or I find the sampling distributions, I see if the conditions are met, and then at the end, I ask a probability question. So in this question, I say that given the coin is fair, what's the probability that I see at least 30 heads out of 50 flips? And so my hint is 30 out of 50 is really 0.6, okay? Because we're always looking at proportions. P hat is a proportion, which is between 0 and 1, okay? And so I'm looking for the decimal version. So I have my normal distribution that I know is the sampling distribution of P hat. Okay, I found that in the step above, and then I want to calculate this probability. So how I do that is I go to StatCrunch, and I go to Stat Calculators, and then the normal calculator, which we've been working with a lot. Okay, if we go back and look at the question, I'm asking what's the probability that I see at least 30 heads out of 50 flips. So I'm asking greater than or equal to whatever number. Okay, so in the probability statement here, I want greater than or equal to. The mean of my normal distribution was 0.5, and the standard deviation was 0.071. That's my normal distribution, and I'm looking for the probability that x is greater than or equal to 0.6. Okay, and so when I compute that, I get a 0.08, or there's an 8% chance, around an 8% chance that that will happen. Okay, so that's the first example. The second example down here is a sampling distribution for x bar question. Okay, so I again ask this probability question after we go through and we check our assumptions and all the good stuff. Okay, I have a normal distribution here. My mean is 4.43, and my standard deviation is 0.135. And the question I ask is, what's the probability that I would see a mean of at most 4.2? At least means greater than or equal to. At most means less than or equal to. So I want less than or equal to 4.2, okay, is the number in the question that they're asking. And so that probability is 0.044 or 4.4%. Okay, so that was all for Lesson 6. All you really need is the normal calculator to do that. Now we'll move on to Lesson 7, which was confidence intervals for P, confidence interval for proportion. And so I have a possible question, or I have a number of questions here. Okay. This was the example that I did about a question asked if the wife in a family wants children, but the husband decides that he doesn't. Is it all right for the husband to refuse to have children? Of 598 respondents, 366 said yes, and 232 said no. Okay, and so I go through and I ask you to complete a confidence interval for P. Okay, and each of these steps can be done with a simple calculator. But oftentimes you will make a mistake, so you have to choose the confidence factor, okay, which we talked a lot about before, and you can use the normal distribution to find those confidence factors. So before we go to confidence intervals, we'll talk about confidence factors, okay? And in the previous slides up here, I talk about how to find those confidence factors, okay? And you do that with the help of StatCrunch with the normal calculator. And so when you do that, you need a mean of 0 and a standard deviation of 1. Okay, we're dealing with the standard normal distribution. And I want to find the point such that the probability that x is greater than that point is 0.025. And that gets me around 1.96. Okay, I ask you for 90 and 99%, so I'll give you a hint. If you want to do 90, if 90% is in the middle, that means 10% are on the edges, or on the tails, and that means on this right side, I want 5%. So instead of 0.025, I put in 0.05, and the number is 1.6448, or round that to 1.645. Okay? I ask in this question a 99% confidence interval, which means there would be 0.005 to the right, and so that number is 2.576. Okay? And so when we go back to the example that I was talking about here, okay, you can go through and do all these calculations pretty much by hand, except for the confidence factor, right? But oftentimes it gets confusing, okay? There's a lot of calculations, some things can go wrong. So StatCrunch has the ability to make the interval for you. Now, before I show you that, that does not mean, and again I'll say, that does not mean that you can just use StatCrunch, okay, to calculate the interval, give me the interval, and then be done with it. Okay? These steps need to be taken. You can use StatCrunch to make sure that your work is correct, but it is not a replacement for doing all of these steps. Okay? So here is how you create a confidence interval for P in StatCrunch. Okay? So let me actually, I found myself zoomed in, so I'll zoom back out. Okay, so to make a confidence interval for P in StatCrunch, I go to Stat, okay, which is where almost everything is, not to Calculator or any of these things, but down to Proportion Stats. Okay. Then one sample, because we're dealing with one sample at the moment, okay? And then it asks you with data or with summary, and then some weird things down here that we don't need to talk about, okay? We have summary information, okay? We don't have a bunch of yes and no's. We have summary information. So I choose with summary, and then it asks us a number of questions, okay? It asks us the number of successes, the number of observations, and then down here it can choose to do a hypothesis test, which we'll talk about or have talked about in lesson 8, and then confidence interval in lesson 7. Okay, the number of successes, for instance, in this question, okay, is 366. Okay, it would be the number of people who said yes here. It's considered a success for us because we're interested in the proportion of respondents who would say yes. A yes is a success to us. So number of successes is 366. Okay. Number of observations is the sample size, 598. And then you go down to confidence interval for P. I'll zoom in a little bit here. Okay, you have number of successes, number of observations. I don't want to do a hypothesis test. I want to do a confidence interval. Okay. Then it asks you for the level of confidence in a decimal. Okay. And so I'm asking here a 99% confidence interval. So I put 0.99. Right. You don't need to worry about the method part. Okay. We're using whatever they have defaulted as. Okay. So then you click compute. And this thing pops up, okay? It gives you down here all of the information that you need for the confidence interval, okay? So it gave you the count, the number of successes divided by total. So then it gives you the sample proportion, okay, 0.612, which we calculated separately here, 0.612, sample size, confidence factor. It does not give you that. Here you have to do that yourself, but it, of course, does take that into account when computing the interval. Okay, it gives you the standard error, okay, which is this part right here. All right, and then at the end it gives us the lower limit and the upper limit, of that confidence interval. And so does that match ours? 0.561 if you round to 3 decimal places. Yes, it does for the lower limit, and 0.663 for the upper limit. Okay, so again, you can use this to check your work, but not as a substitute for doing the steps that I showed you. Okay, now the last thing that I want to show you is lesson 8, hypothesis tests. So for hypothesis tests, it's quite a bit different than a confidence interval, and we've gone through how to do a hypothesis test for P. So here are the slides, okay, motivating example. We'll go down all the way to our actual example here, okay. CEO of a large electric company claims that 80% of his customers are satisfied, so on and so forth, okay, and we want to test that claim. So similarly, for a hypothesis test, as in a confidence interval, okay, you go to stat, proportion stats, one sample with summary. Okay, so it takes us to the exact same window as before, but of course now we're performing a hypothesis test and not a confidence interval. Okay, so in his sample, how many were satisfied? Okay, he took a sample, or the newspaper took a sample of 100 customers, okay, and they got that 73% of them are satisfied. Okay, which means if I surveyed 100 people, 73% of 100 is 73. So the number of successes is 73. The number of observations is 100. Okay, and then I'm performing a hypothesis test. Okay, it gives you the hypotheses, and they are 0.8 and not equal to 0.8. All right. So again, that's good. We'll click compute and a window pops up. Okay, if we look here, it gives you the count, the total, the sample proportion, the standard error. All right. Here it calls something a z-stat. That is our test statistic. Okay, so this side doesn't really change, but here's our test statistic. I have negative 1.75, and it turns out that they also have negative 1.75, which is good. Okay, and then they also give you the p-value, okay, 0.08. So for a hypothesis test, you can use StatCrunch to help you with the test statistic and the p-value, which are two important parts. But again, it's not a substitute for doing all of the steps. Okay, it can help you with doing the arithmetic here in the test statistic and p-value part, but it can't do everything else. All right, and so that's all of the technology that you should need for these 3 lessons.